Hello, hope that you are doing well. We are still here with our technical efficiencies, but we'll be using translog and panel data. And since we have already showed how to do that with Cobb-Douglas panel data, Cobb-Douglas cross-sectional data, translog cross-sectional data. Okay, please you just go and subscribe to our channel. It will help you to have more video when we will be uploading them. And also talking about performance measurements, we have efficiency and we have other things also. But here we'll be talking about efficiency and especially technical efficiency and so on. Okay, think around here, we have the difference within efficiency and between efficiency and effectiveness. Effectiveness just to reach the target, knowing how we are using inputs. Efficiency is taking into account how the inputs are used and see. And now from here, as you can see the output target, that target output is 1010 at company and B, they reach the target, but only that the company A minimize the inputs, meaning then that makes this company efficient. That one is effective, since it can reach the output, but it does not focus on inputs. We have productivity also as measure of performance. We have total partial productivity and total factor productivity. Partial productivity is when we are just doing the ratio of output to a single input. We can talk about labor productivity or land productivity. Total factor productivity is where we are using the aggregate output and aggregate input. Okay, those ones also is the way another way to measure performance. But here we want to focus on the efficiency measurement. As you can see, we have different approach when we are measuring efficiency. Non-parametric approach, parametric approach. A non-parametric approach is what we are called the time variable analysis, and the parametric is stochastic frontier analysis. And now from here, all of them have their characteristics. Can we see for the stochastic frontier analysis, we have production output subject to random shock, not under control of farm manager. Production or core function specification, more important, we have only this one allow only single or aggregate output. Mean that when we are using efficiency, we are measuring efficiency of a farm or farms. You have different output like output 1, output 2. You need to make the aggregate output, all of them, in a single output before to use stochastic frontier analysis. But data development analysis, as you can see also, assume no random shock in production and allow for multiple outputs. When you have farms where you are just measuring technical, you are measuring efficiency, you can consider output 1, output 2, and 3. It allows for multiple output. And so when we are talking about technical efficiency, we have different kinds. We have technical efficiency, allocative efficiency, and cost efficiency. We have already talked in detail about those one in the previous videos. You can also have a look on those videos and so on. Okay, let's talk a bit more about technical efficiency. Here, technical efficiency, when we want to estimate it, we need to use for Cobb-Douglas function, transfer function, but we cannot go and choose like we went. Like someone said, I want to choose Cobb-Douglas, I want to transfer. We need to do some kind of test which can allow us to see which one is the best. Then let's see how Cobb-Douglas a transfer function look like. That's the structure of a transfer function, but we need to linearize it. Having it in linear form until it becomes something like this, what we have around here. Meaning that when we have our data, we need to convert our data in that manner, before to proceed. Here, for example, what just we need here is okay, that one we collected from a farm, because those one final data is a single farm. And now data is collected two times, the time from 1997 up to here. Okay, so what we are getting from the farm, we need to linearize. How to linearize? We need just to apply the natural log on output, on inputs, and now the interactions. The first input, second time the natural of the second input, the first input time the natural of the third input, the third and second input, and now the half of all of them. When we get something like that, at the end we can have something like this. Yes, can have something like this. Yeah. And here, since we need this ID saying that it's the same, which is saying that it's the same company, it's the same company where we are collecting data over the time. Okay. And now, if we want also to see the effect of a variable like experience distance to market on the technical efficiency of the farm, we can add it. From here, we choose how climate change, the effect of climate change on the technical efficiency over the time, technical efficiency of the farm over the time. Okay, then we need also to have this data in data before to run. Okay, let me proceed. Just copy it and go in my data. When I reach there, I need to clear what was there before and put my there what we paste. Okay, then let's go and do whatever needs to be done. I need to tell my data that I'm using panel data. This one. Okay, and now I can run my things. Yeah, I need to consider everything and those interaction things. And then I need to add this variable, yes, there. Yeah, and now I'm using the model df. Now considering this one as I want to see its effect on my technical efficiency. I think it's okay. Can run. Now the result. Okay. Yeah. We not spend the frontier we are using here is shown that we not spend a lot of time here since we are just estimating technical efficiency. Then we can just not talk about those one. And now here the inefficiency is generated. Okay, the like here is the part of the inefficiency, how to see how the climate change is acting on inefficiency. Since it's negative, okay, let's say if it was significant here, we are free to just interpret it, but we have to suppose that it is significant to see how the interpretation is here, because it is important to see how the interpretation can be done. It's like we are saying that climate change has a negative effect on inefficiency of the farm. Okay. Now other we can also just make it easier saying that then the climate change has a positive influence on the technical efficiency, because if we want to use the negativity, we should talk about inefficiency. Since it's inefficiency, things which are generated around here. Then if it was significant, statistical significant, we can say that the climate change has a positive effect on our technical efficiency of the farm. That is. Now, since we are talking about technical efficiency, we need to generate it because that one our purpose. Then predict, we should predict, and now The model uses ESF, and now we can just generate heat here. Now, as you can see, we have a new variable, which is technical efficiency. We'll go and see it even from here. It is generated. We'll go and summarize and see those costs of technical efficiency. Okay, that is, we have them. The mean, all of them are very, very small, near to zero. And let's say that the technical efficiency is between 0 and 1. When the score is 1, meaning that the farm is totally technical efficient, but even it is 0, total inefficient. That those values we have is belonging or in this interval 0 and 1. When it's closer to 1, we can see that the farm is technical efficient, but not total technical efficient. We can see that it's remaining when it is 9, 0.9, and you can say it remains 1% for this farm to be completely technical efficient. But as you can see, all values around here, those costs generated are very, very, very small. The weights are very small. The score are small, near to closer to 0. This farm is technical inefficient along the time. Okay, thank you so much. Hope that this one will help you. If you need more understanding, get in touch with us. How to do that one in R, theta, whatever you are just using. You want to learn about SPSS, Python, or you want to even digitalize your data to be collected, you can just get in touch with us. Our email and address is just around the channel. Thank you so much. Have a blessed day.